Let's build a Node.js Express API from scratch using TypeScript, RapidAPI, and Xata. This is actually part 2 of a series. So if you didn't watch part 1 where we did the setup and defined our CRUD endpoints, go and check that out. In this video, we are going to work on adding error handling and then additional types for our endpoints to make them a little bit higher quality and take advantage of all the TypeScript goodness that we have. All right, so to kick off, this video is actually sponsored by 2 different sponsors, which is RapidAPI and Xata. Now, the cool thing about RapidAPI is not only are we going to end up hosting our API inside of RapidAPI so that we can make money, they also have an extension right inside of VS Code where we can test all of our CRUD endpoints for this jobs API that we're working on. So make sure to install that RapidAPI extension so that you can follow along and test these things along the way. Now, on the flip side, we're also working with Xata for our database. Again, that setup is in part 1. If you need to figure out how to do the setup, go and do that in part 1. Link in the description below. But inside of here, we have a free serverless database where we can define our data and our columns really easily inside of Xata and then pull that into our application. If you need any of the source code, we'll have a link to the GitHub repository in the description below as well. So this will have stepped branches for part 1, part 2, part 3, and any additional parts that we add later on as well. So you have a link to that. You should have all the resources that you need. And with that, we'll go ahead and dive into the code. Now, inside of the index.ts file, we're pulling in the get Xata client from Xata. This is code that's generated from Xata. And they define our client for us in addition to the types for our job that we're storing inside of the database. So we want to actually reference that stuff. And you can see inside of our endpoints, we're already using the Xata client to query all the things that we're looking for, but we're lacking a little bit of definition inside of TypeScript. And we're lacking our error handling. Now, this is one of the things that gets overlooked in tutorials all the time. So I wanted to make sure to take some time to cover that here. So what does error handling mean? Well, if we are calling the database get all function that we have here and something goes wrong, how do we actually handle that error? It's easy to overlook that that's our responsibility to handle that error gracefully and then communicate that back to the calling user of this API. So to be able to handle these errors, we want to use what's called a try catch. And so a try catch says inside of the try block, go ahead and try to run some code. And then the catch says if something went wrong in that code, catch that and handle it inside of the catch. So try catch is going to look like this. You'll have your try, and then you'll have your catch, and you'll catch an error inside of the catch. Now I have a snippet inside of VS Code that I think is handy. So try cat. And that will go ahead and do all this stuff for me, including adding the error to error out to the console, the actual error that we get. So what I'm going to do is I'm going to move all of our data inside of the try catch. So this way, if there is an error, it will catch that, it will log it. And then what do we want to respond to the user with? Well, we could do a res.status. And in this case, we'll just say 500. We're not going to get any deeper into error messages. But in this case, we'll just do a status of 500 to say something went wrong. Then we'll send back a piece of JSON with an error message of something went wrong. Again, there's infinite number or levels of details you could go with error handling. In this case, we're just able to communicate that something went wrong and we're not going any more specific than that. So let's actually test this out. This was on our post endpoint. So we can open up the RapidAPI tab. I've got the post here. I have already created something in the past, so I can create a cool company number 2. And this should just work as expected, where it's going to actually create that piece of data and then return back to us the newly created piece of data. You can see that shows up automatically inside the browser in the database where we can go and view it, which is nice. But what happens if we try to simulate that this call throws an error? So let's just say throw new error and we say, something here. So this is going to basically short circuit this catch or the try and then send us down to the catch. And so in this case, we should get back a result with a status of 500 and an error message inside of the object. So let's go ahead and send this and we should get back, we get our error. And then if we look at the response headers, actually we can go into the raw and we can see inside of here, this is a 500 HTTP or internal server error. So that's exactly what we want. And we want to protect ourselves on each of these different ones. So we could go through and we can add our snippets. So try catch for each one of these, and we can move the main content inside of the try. Let's get rid of this fake error here. And then same thing for each. So I'll use my snippet, and there may be a snippet built into VS Code. Let me know if you already have a snippet for try catch already there. Let me know in the comments. And then I'll do the same thing down in this one, and then move all of this content in there as well. So now, at the very least, we are handling the error. In this case, for the rest of them, we're not actually responding. So let's go ahead and add the response. So we'll res.status 500 with our error message. All right. So we have all those, but we want to, I think we can do a little bit better on how we define what we're going to return. So basically in each one of these API endpoints, we either want to return an object that has a data property, and the data property could be some data, or we want to return something with an error message like something went wrong. Now, I wanted to take advantage of TypeScript for this. So my initial thought was to do a type, define a type of my response. And then that is going to have the form of my response is going to have an error that is a string, and then a data property, which could be any to start. Now we're going to iterate on this and kind of talk through this. And this is also based on a tweet. So if you're actually interested in hearing more about this discussion, I'll add a link to this tweet, but I talked about, or I asked for what recommendation people would have on the best way to do this. And I got lots of different variations for the type. So I'll include a link to this tweet. But I started off by defining that interface, but in this case, we're doing a type. And I had where both error and data could be null. So we could say null or string, and then null or any. So in this case, what we would do is we can now define what we respond back with from our API endpoint. We can define the type definition for this. So we can do this by passing in a type to the response. And we're going to say this is going to be a my response type. So the cool thing about this is with TypeScript, now it's given us problems. It says, hey, you should be returning back an object that has a data property, and the data property is going to be jobs. And then it's saying, hey, you actually still need an error property. So we could return back an error and have that be null, and that will be good. Now, the flip side of this is down here, we would have data, which would be null, and then the error. So basically every call to this endpoint is going to check whether or not they get an error message in the response that comes back from the API endpoint. If not, they can assume that they can take the data property and use that basically as a successful response and anything they need to use it for. So this works, but it's a little inconvenient to have to define error when you don't need it, and it's a little inconvenient to have to define data when you don't need it here. So we can actually tweak this a little bit where we can have this be, I think it was an indiscriminate union, I believe is how this was phrased. I actually don't know the verbiage of that very well, but basically what we're gonna do is say that like this can be the union of two different types. So we can say it's either going to have an error property, which is a type of string, or, so now we do a second one, or we copy our data down here. So this actually formatted this a little bit, not the way I wanted, but here we are. So this is saying that this my response is going to either look like this or like this. So either it's going to have an error or it's going to have a data property. And in this case, we can get rid of null. Okay. So we're starting to make some progress because now we can get rid of this error null. And then in this one, we can get rid of this data. And now that part looks a little bit simpler, which is really nice. Now, one additional thing that we can do is right now we're using the type of any for data. If you hear anyone talk about TypeScript, they'll tell you don't use any anywhere. But the problem is the response from these API endpoints is going to be different based on the different endpoints. So somehow we need to determine or dynamically determine what the type of the data is that's going to return. And this is where generics come in. So we can say that my response is going to have a type of T, and then we can reference that T down here. So now when we define that response is going to be an instance, or it's going to look like this type, the my response type, we also now need to clarify what the T is, what the type of that my response is, which in this case then gets referenced by the data property. So my response is actually going to be a type of job array. And I think we need a closing bracket there. Cool. So this says, hey, that's good because this is actually going to return to us a job array. So that looks like it's going to match appropriately here. And then the other thing I want to do, I'm going to do two things. I like to be more explicit with these returns and make sure we actually return, and then maybe specifically return our status as well. So we'll have each one of these does a return. You'll see more on why in a second. And then we'll have a status of 200, and then we respond back with either this thing or this thing. So that's starting to get us pretty far. Let's take a look at what this looks like in the post example. So we can update this to say we're going to return a response of my response. That response is going to have a type of a job, the created job. All right. So we want to return an object that has a data property that is set to the created job. And that looks good. So that's going to be our created job there. And then there's one other thing to know here is that when we call create, it will either return to us null or it will return to us the object that it actually created. Okay. So the other thing we want to do is go ahead and return, and then we'll do our res.status of 200. And actually we can be more explicit in the return code. We can say 201, which means created. And then down here, we'll add the return here again and have our error. So notice we're starting to get these really strong typings inside of here. And we can actually do one additional thing. Inside of the request, we can pass it types, and we can pass in two empty objects. And the last object is going to be what the request body is going to look like. So this is basically defining what we're going to get inside of the request body that comes to us. So if I get rid of this, let's go back here and just say this is a generic request, and I hover over job. This just says const job any. It just tells me it's a variable. It doesn't know what it is. And if I, just for IntelliSense purpose, if I do job dot, I don't get any IntelliSense. But if I then add the type here where I define that the body is going to be a job, now if I hover over this, it knows it's a job type. I can then call job and then look at its properties like company, geography ID, job link, title. So that is pretty cool. Now we have TypeScript not only on our response, but also on the incoming data that we're going to get inside of the body. Awesome. So we're actually going to do that again. So for our request, coming down to our request over here, we're going to define the type here to get a job. So this is going to be a job. And then we also have, notice params ID says it doesn't exist on type empty string or empty object. That's because this first object here is actually where we define the parameters inside of the route. So we can do an ID and then have that be a string. And so now if I click on params and then just do dot, I get IntelliSense for ID. Now someone was telling me that even if I got rid of all of this, based on the actual route definition here, params will still have IntelliSense for the ID. I don't know why it's not popping up for me. I don't know how it popped up for them. Maybe if it's in a JavaScript file, that would automatically pop up. But in this case, we are going to define our type. So we're going to say that the incoming route params are going to have this format where it's going to have an ID property of a type of string. And we need to make sure that we reference this ID here. So now this update function is going to know that it's got the unique ID and it's got a job type here, which is great. Now there's one thing we need to take into account. What happens if the update fails to find the existing job? Well, we need to handle that situation. And we can check that to see if we don't get an updated job back. So if we don't get an updated job back, that's going to imply to us that that was never found. So we can, or the original one that we're trying to update was not found. So we can call res.status. We'll send back a 404 status, and then we'll send back a JSON response with an error of job not found. Now, the one thing we didn't do here is define the response type. So this response type is going to be a type of my response, and then inside of it, we'll have a type of job, and then we'll close both of those out. So we're saying we're going to return in my response. If we get back data, it's going to have a type of job. So notice we've got our little squiggly error here. We can do our data property and then pass in the updated job. All right, so that should be good. And then we also, just like we did before, we'll return and res.status of 200 and then .json. Cool. And then down here, same type of thing, we'll return and then we have our error inside of JSON. So notice these functions now get a little bit longer as we start to pay attention to defining our type so that we can control what we import or what we receive as parameters and then return, and then also just handling the error handling. So we'll do the same thing for the request down here. We want to get back inside of the type. We want to get back something with an ID of string. Then we can have an empty object. And since we're not getting body out of here, we can do another empty object inside of here. And actually that bracket should close off here. All right. So now we're saying we are going to get an ID property here. So that's where we can reference it there. And then our return type here is still going to be, we're going to return a my response with a type of job. All right. So I did a little bit of formatting there for me. Instead of just sending back the deleted record, we're going to send back an object with a property of data, which is the deleted record. And we have the same problem that we had a second ago with our update, to where deleted record might not come back. It may not give us a deleted record if it couldn't find one with the ID that we sent. So in this case, we can say if not the deleted record, it's going to be the same thing we just did before. We will return a res.status. This will be a 404, so not found. And let's make sure we spell return correctly. So a 404 JSON, and then we'll have the error job not found. All right. And I noticed this error down here went away because we've now handled the case where this might return null, if that's the case. So everything should compile. Let's go back into all of our endpoints and see if all these work. So let's do our get. We should get back a list of jobs. Awesome. Let's do a post to create another one. So this will be cool job number 3. We can go ahead and send this. If we look at the text, or the JSON text here, you see we get our data. If we then go to update a job, let's grab this ID and let's come into update this job. So we'll need to update this path up here of where we're sending the request. And then we'll update the company to be super cool company name. Let's say extra cool company. So we see something different. So this should hopefully do that. And also if we go back into Xata, we see that has been updated there as well. Awesome. So that looks good. And then we can go with the delete. So remember, we have to change out the ID that's in here. And I'll paste in that same one that we just copied. We'll send the request to delete it, and we should get a response, although it looked like something broke. Let's see. Cannot set headers after they're sent to the client. I bet inside of our delete that we didn't do a return. Oh, actually, so this one should be inside of the catch. And then I wanted to update both of these to be return and then also include the status just to be really clear on what we're returning. So let's do return here as well. All right, let's try that one more time. We can actually grab one of these IDs. So I can go and copy this from Xata. And let's go into request 4. And let's pass in this new ID. Send this. Hopefully we get cool. That response looks good. I'm also going to add a description for this. So let's say delete job by ID. And then in the update job, I'm going to do update job by ID as well, and then create new job and then get all jobs. The last thing I want to do is actually sync all of these endpoints into the RapidAPI hub, or actually the studio. So you can see we have them listed here, but I just did a couple of small changes. Again, this setup was in part 1. So I'm going to sync this with RapidAPI. And when I do, we should see the updated description in here. So update job by ID. Okay, so it looks like that made it through as well. So we've got all these now saved inside of here. These could be shared with other people so that they could do their own testing as well. We can have environments and different things, but this is going to do it for now. So in this video, we walk through our CRUD endpoints in a Node.js and TypeScript API using Express. And then we added error handling and some additional types. We had some help with our types that came from the code that's generated from Xata, where they generated the types for our data. And then we get to reference that actually here. And then we get to reference that inside of our code. So we have TypeScript everywhere to take advantage of the benefits of TypeScript and really have full control over this. So that's going to wrap up this video. In the next one, in part 3, we're actually going to work on deploying this, and then we're going to not only have it fully hosted, but also deploy it to RapidAPI, where we could, in theory, sell this and make money off the data that we have for this API. So I hope you're enjoying the video. If you have any additional questions or extra features that you would like to see, let me know in the comments below. I'll certainly take those into account. But thanks for checking out the video, and I'll catch you in the next one.